Nah.
It gets worse.
I don't know how much to write.
Already there in capitals.
Yes, it's on. I'm gonna go based off what the answer he says, because I'm not really exactly sure why they're multiplying by x minus 1. Okay, so take it with a grain of salt, we'll go with the best I can figure out. I should make that bracket bigger. Okay, so the whole goal is to find the limit of f of x, okay? So if I take the top, the limit of f of x minus 8, that would be equal to the limit of, this is what I started with, but how did I, like those would cancel each other out. Does that make sense? Like I'm adding things in there that I don't need. Okay, now, here's why I would do this. If I want to find the limit of this, if I split this up, so the like limit laws, I think is what's called in your book, okay? If I split up multiplying, that's like I find the limit of the first part times the limit of the second part. Okay, so what is the limit as x goes to 1 of x minus 1? 0. Right? Because if I put in 1 minus 1 is 0. So this is going to give me 0. What's the limit of this one? It gives it to you in the directions. 10. So 10 times 0 is 0, right? Okay, here's why I'm not sure why you have to show that. If I go backwards, then still, this is why I'm not sure about that part. Okay? Okay, so I went backwards from here. Now if I take away the 8, that's the same thing as going from the limit, x goes to 1. If I subtract the 8, and then I would add an 8. Okay, so this is taking one part off. Now we're going from here to here, taking the 8 off. So if I take the 8 off, in order to get the f of x, I would have had to add 8. Okay?
Wait, I'm confused why you set it up like that in that second part.
This part right here,
Yeah, like, okay, they give you those two at the top, like the first line. But then, why do we set it up like that?
okay, this is one part I'm not exactly sure on, except for we have to simplify this backwards because we're just finding the limit of f of x. So the first thing we can get rid of in a function like this is you would get rid of the denominator. So if I already have the denominator in there, how I get rid of it is multiplying by that. Okay?
So did you have to do that to the other side too, to make it equal, or?
No, because this isn't really an equation. This is just saying the limit of this is that. But this isn't really like an equation.
So then when you get, that like second part,
This part right here?
yeah, the reason that you split it up is because of that property where you can like divide
Yes, like so the property like you add, you can split it up to do adding and subtracting. So multiplying this up twice.
And
With
then-
here notice is 10, this is giving me 0, so I know I can get rid of this.
So that one's just 10 because it tells you, and the other one is 0 because of the distribution.
Cause if I put in the 1, yes. Have you guys you got to that one, like
Yeah, it's
section?
like one of the steps, right? Or like
Right.
one of the things you can do with the walls.
You can plug in the number as long as it doesn't make it undefined. Things undefined, that's when you have to try like the factoring or approaching, which we're gonna talk about today, hopefully. Approaching from the right hand and the left hand. Have you done that? Like,
Yeah.
did she talk about this on Friday? Like, if it approaches like that?
Yeah.
Okay.
Ms. Draper talked about that.
She did? Okay. Okay, so then we got rid of this part, so now we gotta find just f of x. So if I'm given the -8, the +8 is gonna be what gives that. Does that make sense?
So you just do the
But
opposite.
then wouldn't it just make the limit 1?
Well, it's gonna make the limit 8.
Why?
That's what I'm not sure on, okay? That's why I'm not quite sure how to go from there to explain it. This part makes sense to me. Okay? The only thing I can think of is if I know, here, I'll just go with what they put and then I'll explain what I think in my head. You can take it or leave it, I don't know. Ms. Draper might be able to explain this better when she gets back.
Is it maybe one of the properties?
Okay, so if I use the properties to split this up, this part goes together. Okay, and then I split up the +8. Here's the part I'm not sure. I understand how this is 8. I'm not sure how they get this to be 0. If I'm real honest. The limit as x approaches 1 at 8 is definitely 8. So 8 + 8 is going to be 8. If I split this up, because adding, this part went together, and this part was separate, so I can split this one into 1. Then I have this into 1. The limit of this is what, if anyone has any ideas, like I've been thinking about it, this gives you 0, this gives you 8, add them together, you get 8. So the limit of, as x approaches 1 of f of x is 8.
Does it have to do with the x minus 1 if you multiply it by
By the 0?
Yeah. And then you add 8 to it?
I mean, if this did prove us that gave us 0,
Yeah.
so then we, I guess, yeah, assume that that's already 0, since we got 0 from here. That's the part that I'm like fuzzy on, the part that I'm nervous about teaching you guys. Is the connection part that I'm not 100% sure on. We're off to a great start, aren't we? If that's the only one you don't have, you have questions on, that's pretty good.
How is it? Well, and then
Through
do
all
four.
the math I've learned, I've never known that 1 minus 8 would be 0.
1 minus 8 is not 0.
In
But
this
we
case it is.
No, this is f of x. This is a function.
But it's 1.
No. This could be x squared plus x plus 10.
Okay, now I'm confused.
This isn't x, this is f of x.
I thought you take that x though and you put it in for that.
You can on this, because this is an f of x. This is just a variable.
Oh.
Wait, maybe
okay.
it's 0 because if you plug in 8 to f of x, 8 minus 8 equals 0.
But how do you know to plug
Why
it in?
did you
Well,
plug
I
it
don't
in?
know.
I
was like, wait, whoa.
Function would end up,
It's
like,
It's gotta be one
It'd
of
be like
these
8
laws.
times x or something. And
I'm
then
not
x
sure
would be
about
not.
Is it minus or
Because
plus?
it's as x approaches.
Right here,
yeah.
this is minus because of what we started with in the problem.
But how would you define it? You would?
No, let's move on.
The only thing I can think of is because this gives me 0 when I multiply these together. If I carry that on, that's still gonna give me 0. Okay, but I'm gonna have this part, this is gonna be 8.
How is that still gonna be 0?
Well, 10 times 0 is 0. So if what I'm doing is like, I'm breaking it down further. If this is 0 right here, then that means this is 0. Because that's what we just found.
So we found x minus.
But if that's.
No, we didn't. We found f of x minus 8.
But if that's 0, isn't, if you divide anything by 0, it's be 0, not 10?
Okay, correct. But,
Oh,
you're right. I mean, what you're saying is right. But your goal is to find the limit of f of x, which f of x, in order to get this to be 0 would be 8. Okay, but I think they're just giving this to you as a number, just saying that this would be what the case was for any f of x, but I don't know what the f of x is.
so they just found.
But yeah, 0 divided by anything would still be 0.
Could you just solve it like
Problem is we don't know f of x, so this is like theoretical, which is the part you guys hate. You have to think about the theoretical part of it, not knowing what the equation is.
could you just solve f of x minus 8 over x minus 1 equals 10, like in a regular equation?
That's what she asked, but it's not an equation, because this is just saying the limit of this gives you a number, but it's not actually an equation. Limits aren't like equations.
Yeah.
Okay. Okay, so you're good now, well, I don't know good, but you have all your homework questions answered up to 2, 3.
Yes.
2, 3, where did I put my paper?
I have none.
I left 2 papers, that's good.
Do you want, notes from what she gave us for Q4?
I'm okay, I mean, I wrote my own, but you told me you have the definition, like you wrote down this.
It's like on page 106,
Like if 0 is less than the absolute value of x minus a, less than delta. Okay, do you understand that delta and epsilon are just numbers?
No.
She just told you.
Okay, so when you get to calculus and higher, when you're trying to talk about some number, they're going to start using Greek letters. Okay, so in this case, delta will be used and epsilon will be used. Okay, and I know a good question is gonna be, well, how do I know? Did she do an example on like within 1/10 or 100th or
Yeah.
like what the error is?
Yeah, she did.
Okay.
She did like apples and millionaires, like, no?
I mean, yes,
Yeah.
but that doesn't help us really understand what
She's saying like
I like the real
millionaire,
problem.
if a millionaire has like a bunch of money, then giving some of it's not gonna matter, or losing like a couple hundreds isn't gonna matter.
She's saying, like, what's the area that you're still a millionaire?
Right, like you still become a millionaire. Okay, so you were able to find your gamma and then, or not your gamma, your delta, and then you use the formula to find epsilon.
Yeah, our delta was dollars.
Okay, okay,
Or $100 bills or something.
okay. And you already talked about right hand and left hand limits. Did you write down the definitions of those?
Could you do that again?
No? Okay. And then we'll do an example or two. Okay, do you know what a left hand limit is?
When you come from the left side.
When the airplane is coming from the left side.
Coming in from the left.
Yeah, that was how we had fun with
This
this
phrase
reading.
described as a air traffic
And we
controller.
learned about in an equation there.
She was really excited about that.
I'm sorry that I'm not as, I went over to your house yesterday, and I'm not as chipper as you, as much as I wanna be, I'm not.
Does she still have the giant ruler in her living room?
I don't know, I always kept saying her clock. Like, cause she has like on the outside of the 1, like there's a 5, and then with the 2, there's a 10, so that her kids can like read the clock. I thought that was pretty cool. Except for the 25 was missing, I think it might fall.
Are
my like deltas look like 8 sometime, and I'm sorry.
Just do an acid.
They're still beautiful just the way
Oh, thanks.
That's called a delta, and then it uses the epsilon.
Epsilon, yes. Excuse me. Okay, so when you're thinking of like the regular limit, like the precise definition of a limit, and you're talking about as it approaches just a number, not thinking right-hand side or left-hand side, just approaching the number. Okay, well, when you're talking about that, you're still talking about epsilon has to be greater than 0 and delta are greater than 0. Because you're still looking at the positive distance between those two numbers. Okay? So like, when I talk about delta, that's the distance between my x and my a. Where I'm going from, that's my what I do with delta, okay? Then my second part with epsilon, that's the distance between my function and where my result is, like whatever the limit is. So like on this one, it was 10. So this would be f of x minus 10. Okay, that's going to give me my, whatever that is has to be less than what my epsilon is.
What did you say? The delta is the distance between.
Where x and a are. So like where you start,
Uh-huh.
so x and whatever this is, whatever you're plugging in. So this would have been, like on this problem, it would have been x minus 1. Okay? So this is what's talking about what happens on the left-hand side, and then you're going to talk about what happens on the right-hand side. Because if the right-hand side and the left-hand side aren't the same, then your limit doesn't exist. So a graph can approach a number from one side, and it looks like it's going to approach 1, and then maybe from the other side it looks like it's going to approach 3. It can't approach two numbers. So that's how you determine when limits don't exist. Okay? So for the right-hand limit, very similar definition. And then this is like, we'll talk about infinities tomorrow. I want to make sure you guys get an example of the other ones. Was it a struggle to get up this morning?
Yeah.
Yeah.
And then if you didn't go to sleep.
What?
You didn't go to sleep? You didn't go to sleep at all?
Before 6.
Oh.
Huh.
I think this is the third day that I've been up before 6.
Well, you're gonna have 4 more days.
I had 4 yesterday.
To freaking hunt.
Yeah.
That's stupid. I was gonna be really mad if you would have shot those 2 little deer that were having a good time.
I was supposed to go skydiving on Saturday and got canceled.
Yeah,
Why?
why did they keep canceling?
Because it was raining in Indy. So I'm going this Saturday at 11. And I got myself all hyped up. And then my aunt's going and now my grandma's going.
We did
We've
one
done
proof
this.
with Miss Freeze.
Did you already do this
We've done
one?
this
Yeah.
one.
Of course you would pick the same one I did.
Oh my gosh.
Okay, let's just do one of your homework problems then.
Number 4.
No, number 1.
We've done
Number 1,
it.
number 4, graphing, and I kind of want to talk about this tomorrow. Do you want to talk about this today instead?
Okay, we can do it
we
next-
can do it tomorrow.
I just don't know how to do number 4.
What about
We don't know how to
16?
do 1 either.
Yes,
Oh,
one's
yes.
easy. She'd done it.
I know.
She's done.
Obviously, we've done it.
Did you have to do like, what was the next one, like 15 maybe?
16.
16. Then we can talk about the diagram, then I can go back to number 1 more. How about that?
Sounds
Sure.
great.
We'll like circle around.
Got it.
As long as you remember.
So this is 16.
16.
Yeah.
Oh, what page is 2.41?
14.
Pretty sure he gave us the answer number 1, didn't he?
Yeah.
Okay, so the first part of the limit is proving what?
That the limit is x approaches. Oh.
Okay, so the first part of your limit, you gotta look at your definition. 0 is less than the absolute value of x minus a, less than delta, right?
Oh, yeah.
Okay? Did you write down the precise definition? You told me you didn't already.
Yes.
You didn't?
I guess we're supposed to, I didn't.
Okay, well, here's the 2 parts you have to do. You have to deal with this part, and then if that's true, then that means this is true. Okay? For delta greater than 0 and epsilon greater than 0. Okay, so what's my A? 4. So, right? So, I don't know what delta is. I know my A is 4.
How do we know that's the part of the precise definition that we use?
Because that's what it says to do in the definition. So if you want to prove it's true for any delta greater than 0 and any epsilon greater than 0, these two, then it says if this, then this. So if we can prove this, so I know you haven't talked about truth tables yet, because that's not really a calculus thing, but you talk about proving proofs, okay, which is what I'm doing in grad school right now, it's a table. Okay, so if you talk about proving proofs, if I can get my epsilon here, that fits over here, then we're good, we've checked it off.
So A is always going to be the number X is approaching.
Whatever it's approaching, yes.
I did too, and I was like, why is there a random line after L?
I was like, you forgot your other absolute value.
Instead of absolute value.
We thought it was
not.
if instead of absolute value f of x.
Like instead of absolute
Like
value.
the word.
Oh, gotcha. I'm looking down here and I'm like, there's no if there. I gotcha. Okay, so what's my f of x?
2x minus 5.
2x minus 5. So f of x is what you're giving, your function right here. So 2x minus 5 minus, okay, what's my L?
3.
3 is less than my epsilon. Okay, in order to prove this, I have to make this right here look like this right here. If I can do that, then I can get my epsilon, which means I know what my delta is. Okay, so I gotta simplify this to somehow make it look like the absolute value of x minus 4. Does that make sense what I'm saying?
Yeah.
Okay, so what can I do first?
We can find mine.
My like terms, right? So I have 2x minus 8.
Well, 2.
Pull out the 2. And then what can I do from there?
Divide by 2.
Divide by 2. Okay, so why do I say that I know that delta is epsilon divided by 2?
Because they're both greater than x, absolute value of x minus 4.
Okay, so look, if I, this 0 you can't change, 0 is always going to be 0. Right, but isn't this the same thing as this? So this is absolute value of x minus 4 has to be less than delta. Well, I already know x minus 4 has to be less than epsilon over 2. That means that is my delta. You just proved that the limit exists.
Can
Okay?
we go back through and talk about it now? Is that like that?
What do you want to talk about?
Oh, well, no, I mean like, we had to go back through and talk, like,
Like, wait,
we pretty much just did the whole thing. Yeah.
She's still gonna plug in.
Like,
We did.
have it subscribed. Like,
Should we
after
make
we
you
did
handwrite?
This is
we
all
ran
what we
right,
did
and then we
for-
had to like make the equation even instead of like piece of it.
If you want to.
I don't want to do
I
it.
don't want to do it.
I don't think you have to prove it the other way,
Cool.
which is what she did. I mean, Miss Draper might tell you differently. I think this is enough proof. Okay? If you want to prove it the other way, all you're doing is working backwards.
Because you're already proving it, because you're working.
Yes.
Honestly, the point of that is just like the same thing that we've been doing, that they've been telling us to do, is just like check your work.
Right.
I think that was,
Since
Okay.
we
was
own
freeze.
it.
Do you understand the graphing part of this?
No.
No.
Kind of.
Good for you, Corey.
Corey volunteered to teach the class for the last 5 minutes.
I don't understand it.
Oh, but this we're gonna do for tomorrow. No, we're doing the graphic part.
That is number 4, Hannah.
Oh.
Goodness.
So, are we always going to use that over there, like that part of the precise definition of the limit to do these problems?
You will for,
Like, I'm kind of asking, like, how do I know when to use, like, oh,
like,
never mind. I just had to think that one through. Because I didn't
if you read the
register in my
directions.
brain that the other part was right there. And so I was confused. I thought we were picking a part of it instead of like the whole, you know what I mean?
Sure.
Okay. Disregard me.
Okay. Alright, so if I have my line 2x minus 5. I'm not a very good graph drawer. I know this isn't gonna look right, but we'll just do like a random line, because I know it doesn't cross the 0.
Is this for this problem?
Yeah, then they have the graph on this one?
We can do number 4.
I know you're obsessed with number 4, but we're still doing the same
Oh, so
problem.
we're doing this one
So
too.
this is number 16. It's not registered, but we're still doing the same problem.
Well, I did whenever she said.
So then you have your epsilon, right? Okay? Then on each side of that, what do I have?
Epsilon plus.
No, it's
Plus or minus what?
A.
It's essentially this. 1/2. So I can go up or down.
A minus epsilon.
Okay.
Wait, can you do that again? I missed it.
You also have your delta.
Where's the video?
Okay, so on your, I know this isn't probably not gonna make sense, but like on your y-axis, you're gonna have your epsilon. On your x-axis, you're gonna have your delta. And they're gonna meet up. Okay? I don't know if they make these straight lines and the other one's dashed. Okay, then on each side of those, you have like you're talking about millionaires. Okay? You have the, I don't want to call it gap. But you have the spacing like that, the leeway. There's that better, like the leeway to make it. So like we talked about like the error was, you probably did the first problem was like probably between like 0.1 or something. Okay? So if I'm looking at this one, what are my numbers between?
Dan Clinton, would you come to the office?
Okay, what is this number right here really? What's my limit?
A half.
3.
Wait, 3.
Why? Because the L is the 3.
Okay, so then this could be
E3.
3 plus my epsilon, right, because that's going up.
Why is it E over 2? I thought that was.
Wouldn't it just be,
How do you make
Delta.
it?
Why isn't it just regular E?
Why is it 3?
Why is
Because then it would be delta, right? Delta.
Yes, you're right.